This is a small and dangerous passage in the Red Sea towards the Suez Canal. It's a crucial maritime route where ships from around the world traverse, providing the opportunity for the Houthis to launch attacks when they are within 80 kilometers of a target. Now let's explore the various modes of weaponry employed to target ships. One of the methods involves the use of Soviet-era anti-ship missiles, such as the P-15 or P-21. These missiles are launched with anti-ship warheads that operate by utilizing an air-filled cavity and a conical liner. Notably, the explosive is intentionally inverted, and this configuration is meticulously crafted to generate a high-velocity jet of heat. Additionally, there is the Iranian-made Shahid drone, which involves launching multiple UAV to overwhelm a warship's defense system. These piston-driven drones can loiter for some time and utilize anti-radiation seekers. They are designed to detect and hone in on an enemy radio emission source to strike its target. Finally, we have the Russian or Soviet-era missile that has been re-engineered by Iran to function as an anti-ballistic ship missile. These missiles use solid propellant boosters to effectively thrust the missile to a desired altitude, activating the second-stage liquid propellant engine, as shown in the upcoming video. So stay tuned and don't miss a beat. This strait is known as the Bab el-Mandeb, meaning the Gate of Tears. Cargo ships must navigate through this passage to reach the Suez, a crucial waterway responsible for managing approximately 11% of global trade. The Suez serves as a significant maritime choke point, highlighting its pivotal role in international commerce and navigation. Ships from around the world traverse this strategic route, but the Houthis militants have exploited this waterway to attack shipping vessels. Now let's examine different scenarios of how they execute these attacks. Scenario 1. If a ship is within 80 kilometers or 40 miles from land, which is the desired range, there is a possibility of the missile they would use to attack ships. A Soviet-era P-21 with solid booster and liquid fuel anti-ship missile, produced during the Cold War, is employed for the attacking mission. When launched, the first stage booster fires off for 2 to 3 seconds, after which the second stage takes off. It searches for a target using analog radar. When locked and ready, it can destroy a ship using a hollow-shaped charge warhead. This has the potential to either destroy or sink a cargo ship if it hits at the right angle. Scenario 2. This involves the use of a Soviet-era missile that was re-engineered by the Iranians, converting it into an anti-ship missile. The converted SA-2 missile can be launched from within 45 kilometers or 28 miles from the target. Take, for example, the U.S. destroyers sailing through the Red Sea. The Houthis forces fired 3 anti-ship ballistic missiles capable of traveling at a speed of Mach 3.5, along with 2 land attack cruise missiles in the southern Red Sea over a 10-hour period that commenced at approximately 6:30 in the morning on December 26. These actions create a psychological impact and disrupt trade routes. Fortunately, the U.S. destroyer's defense system kicks in and successfully destroys the incoming threats. As a result, there was no damage to ships in the area and no injuries were reported. Scenario 3. Remember those loitering Shahid drones developed by Iran? These are among the most common attack drones used against shipping vessels or oil tankers. When a general cargo vessel sails through the Red Sea, they can be launched and loiter around for some time until they find a suitable target, such as an oil tanker. They dive, producing a sound similar to a motorcycle screaming down on them at a speed of around 115 miles per hour, which translates to approximately 185 kilometers per hour, damaging the ship with its 50-kilogram warhead. The drone is carried on a simple truck carrier that looks like it is carrying cargo. However, inside this cover are swarm drones. Each launcher in a standard truck container carries 5 Shahid. At the press of a button, the drone is launched with rocket-assisted takeoff. This rocket-assisted takeoff is ejected just like this. This was installed to reduce weight and increase efficiency, allowing the piston engine to take over. Hence, the motorcycle sound. These are low-budget loiter munitions that cost around $20,000 to $30,000. They are launched in swarms as they usually use inertial guidance and radio to track its target. Scenario 4. For bigger ships or warships like the aircraft carriers or the U.S. destroyer Berkeley class, this is how they would have attacked. The first stage involves launching multiple drones to overwhelm the warship's defense system. In the second stage, a couple of Soviet-era anti-ship missiles like the P-15 or P-21 are launched. These missiles travel at a speed of max 0.95 and can pack a punch when hit. The third stage involves launching converted surface-to-air missiles into an anti-ship missile. These flies at a speed of around Mach 3.5, capable of seriously damaging a warship. Let's examine its various components and their functions. Positioned at the forefront is the DS antenna device, a straightforward analog design equipped with a homing conical scanning radar sensor. Sitting just behind the antenna is the warhead, boasting a weight of approximately 1,000 pounds, equivalent to 454 kilograms. This warhead takes the form of a hollow-shaped charge. Let's take a look inside the warhead. There exists an air-filled cavity and a conical liner. Notably, the explosive is intentionally inverted, and this configuration is meticulously crafted to generate a high-velocity jet of heat. The primary purpose of this formidable jet is to pierce or obliterate armored steel ships. This design is to create a devastating impact, making it a potent weapon for naval warfare. Moving further to the back is the oxygen tank required for the liquid fuel propellant, positioned just behind it. But wait, that's not all. They even have a booster required just for the initial launch located outside the missile. This is how it works. At the top of the rocket is the ignition tube, initiating the combustion of a precise mixture of fuel and oxidizer in a motor case. The motor case acts as a robust pressure vessel, containing the intense forces within the combustion chamber. The propellant-burning zone of the core of the rocket is where the reaction occurs. As the solid fuel and oxidizer react and burn within this zone, they generate extremely high-temperature combustion gases. The nozzle is designed to accelerate the flow of gases and direct them out of the rocket's rear end. But don't be fooled by this low-budget Soviet-era tech. They even have an analog software device and control unit. All these components work hand-in-hand with the radar unit in the front, directing the steering gear that controls surfaces and fins towards the designated target. They utilize a surface-to-air missile, repurposed to target ships and designated as the Mohit missile. Remarkably, this missile is a Soviet creation of the S-75 Dvina or SA-2 guideline. Dating back around 70 years, but it underwent a transformation through Iranian engineering to incorporate advanced missile guidance systems. Enough history lessons, let's take a look inside this bad boy. The launcher plays a crucial role in directing the missile toward its target, boasting a 360-degree turn radius for optimal precision. This is the size when compared to a person. As you can see, its dimension is pretty huge. Positioned at the forefront is the radio proximity transmit antenna and proximity fuse. Just behind these components lies the warhead. Noteworthy is the fact that this is a two-stage missile, necessitating the presence of an oxidizer tank and a second propellant tank. Moving towards the rear, we encounter the compressed air tank and, intriguingly, an autopilot module. Additionally, there's the turbopump gas generator propellant tank and the liquid propellant sustainer power plant. At the base, we find the boost power plant, featuring a burn duration of 2 to 4 seconds. This boost effectively propels the missile to a desired altitude, activating the second stage liquid propellant engine. This combination enables the missile to achieve an impressive range of around 18 miles, equivalent to approximately 45 kilometers. We make original 4K 3D animation with a small team of animators. So please support us by subscribing and dropping in a comment for more exclusive engineering animations made just for you guys.